Hello, my name is Beth Dixon, and this is a video set based on Vicki Borlaug's PowerPoint presentation on the binomial distribution, finding the mean, standard deviation, and ordinary and unusual values. I wish to thank Mrs. Borlaug for allowing me to use her PowerPoint to make this video for students. Let's look at our example. The probability that a farmer will use the Grow More fertilizer is 0.186. Let X be the number of farmers who use the Grow More fertilizer in a group of 243 randomly selected farmers. Part A asks us to find the mean and standard deviation for the number of farmers who use Grow More fertilizer in a group of 243 randomly selected farmers. And we'll get to Part B when it's time. Let's do Part A. Is this a binomial? Yes. We have two outcomes. We either use the fertilizer or not. There's a fixed number of trials, n equals 243. The probability of success is 0.186 for every farmer we look at, and one farmer using the fertilizer does not affect the probability of the next farmer using the fertilizer, and since we randomly selected the farmers, we'll assume that they are independent. Our success is that they're using the Grow More fertilizer. Our number of trials is 243. Our probability of success is 0.186, which gives us our probability of failure at 1 minus 0.186, which equals 0.814. X is the number of successes, which can be 0 through 243. Our mean is equal to n times p, which is 243 times 0.186, which gives us 45.198. Our standard deviation is given by the formula sigma equals the the square root of n times p times q, which gives us the square root of 243 times p, which is 0.186, times the q, which is 0.814. As you place that in the calculator, be careful with your parentheses that you don't stop the square root too soon. That gives us 6.0656. Would it be unusual, the B part asks us, would it be unusual to have 38 farmers use the Grow More fertilizer in a group of 243 randomly selected farmers? Justify your answer. Let's use technique number 1 using the z-value. Remember our mean and standard deviation from Part A. Note a value will be considered unusual if it is more than 2 standard deviations from the mean. The z-value is the number of standard deviations from the mean, and z equals x minus the mean divided by the standard deviation. And we have our number line here, which illustrates that better than my words. Let's calculate the z-value, since we're asking about 38 farmers using the Grow More fertilizer, that will be our x, minus the mean of 45.198, divided by the standard deviation of 6.0656, calculate the z-score, and that gives us negative 1.19. Where does that fall on our number line? Well, that falls slightly below the negative 1 in the ordinary range and within the 2 standard deviations. Therefore, our conclusion is that this is ordinary or not unusual. Better just to say ordinary. Let's use technique number 2 using the raw data value. In this case, we have our mean and our standard deviation, and again, a value is considered unusual if it's more than 2 standard deviations away from the mean. Let's draw a number line, placing the mean in the center. Using the standard deviation, let's count 3 standard deviation jumps in both directions. Adding the standard deviation of 6.0656 to the mean gives us 51.2636. Adding the standard deviation to that number, we get 57.3292, and adding the standard deviation one more time, we get 63.3948. We will repeat that process by moving to the left, and in this case subtracting the standard deviation. 45.198 minus the standard deviation leaves us 39.1324. Subtract the standard deviation from that number leaves us 33.0668, and a third jump by subtracting the standard deviation again leaves us 27.0012. Where does 38 fall on the number line? Each tick mark, well, before we get there, each tick mark represents a standard deviation jump. So 2 tick marks down and 2 tick marks up, that represents our ordinary range, and outside of that represents our unusual range. Where does 38 farmers fall? It falls slightly more than 1 standard deviation below the mean, but it is well within our ordinary range. Therefore, this is an ordinary value. Here are some exercises for you to try. Thank you for watching this set of videos, or I guess this one video. I think I covered it all in one video this time, on finding the mean and standard deviation of a binomial distribution. I do have other videos on binomials that may be of some help as well. And as always, Walter State students are welcome to stop by and see me in the math lab in MBSS 222. Thank you.